Branka Dimitrijević, and I will moderate today's webinar. As always, at the start of our webinars, I have to say that we disseminate outcomes of feasibility studies and academic consultancies undertaken by 7 Scottish universities in collaboration with small to medium-sized enterprises in Scotland. The focus of these studies is sustainable building design and refurbishment. And the project Kickstart Online is funded by European Regional Development Fund and Scottish Government. This is a live event, so it can happen that there is a fire alarm. If that happens, we will have to stop and we will continue later. If you can join us, that will be fine, but if you cannot, then you will be able to watch a video recording of this webinar in due course. Online viewers can start using chat facility at any time, and the questions that you ask will be answered after the presentations. The event will close around 2 o'clock. If some questions cannot be answered at that time, they will be answered by email by our speakers. Today's webinar is about a retrofit of solar photovoltaics on existing housing. This was a study that was undertaken by Edinburgh Napier University in collaboration with 3 housing associations in Scotland. Our speakers today are Julio Bross Williamson of Scottish Energy Centre at Edinburgh Napier University and John Stinson, also from the same Scottish Energy Centre at the same university. And we also have representatives of 3 housing associations, Mr. Michael Huey of Malcolm Homes, Mrs. Wendy Farmer of Port of Leith Housing Association, and Mr. John McMurrow of Easthall Park Housing Cooperative. I would kindly ask our speakers now to start with their presentations.
Thank you very much, Branka. Welcome everyone to this webinar in which we have combined 3 feasibility studies dealing with the same problem, the same request in terms of the solar PV feasibility into existing housing stock. This is a unique opportunity to bring housing associations and to also provide them with this service of a feasibility study. I will first start with just an explanation of what this webinar will include. I will talk about the project partners and who we are, following with a brief introduction, the motivation of the feasibility studies and the brief, talking slightly on fuel poverty and how that has been one of the drivers for these projects, and also doing an overview on the methodology applied to all of the 3 feasibility studies. And then we will follow on with the 3 individual housing associations and explaining briefly on some of the case studies that we've selected, followed with some conclusions. The project partners for this combined webinar, bearing in mind that all of the studies were done individually, have been the 3 housing associations, Malcolm Homes, located in Edinburgh, also Easthall Park in Glasgow, Easter House area, and Port of Leith, Edinburgh, in the Leith areas of Edinburgh. We are, as part of Edinburgh Napier University, a consultancy office called the Scottish Energy Centre, and we have provided this service to the housing associations. 2 of the above mentioned housing associations are regarded as registered social landlords, with the exception of Malcolm Homes, who are a private arm of Dunedin Canmore Group, and Dunedin Canmore Group are a housing association. Sorry, is regarded as a registered social landlord. So there's just that slight difference there. As an introduction, I think it's important to highlight that the feasibility studies that we have here will be looking at both the technical and an economic viability of the work, and how we can bring renewables, micro generation into existing households, and looking at the constraints around it. There's obviously that priority of looking at reducing electricity demand in the tenants and the occupiers of these houses, whether it's in its household use or in communal areas. So that was kind of part of the main focus in the reports. A lot of one of the kind of priorities also was to look at reducing carbon footprinting of the homes, and that was a core element within the results, and how that would count into positive reductions. The work carried out really looked at the viability and how well these buildings could be adapted, and this technology introduced and installed into them. This was a kind of planning stage and an introductory stage into assessing these buildings. We looked at elements, for example, the roof viability and any site constraints around the buildings. We also looked at sizing of the technology and the PVs themselves, and how they would adapt properly to that roof in question. And also combined with that, how the tilt of the original roof was going to be ideal or not, and if not, look at alternatives of making that work and produce more energy. And also looking, as I've mentioned before, the economic payback periods, and with that in mind, the introduction of the feed-in tariffs, this government incentive that's been quite important in the last year and a half. And that would really give us a yearly generation of each roof, of each potential building, and looking at how the energy savings, the energy bill savings, together with the feed-in tariffs would justify this investment. What the studies didn't look at was looking at specific design of the technology and the panels. We really applied a lot of the available technology, current available technology. So no further investigation on their quality and their efficiency was done. Looking at structural viability, that wasn't part of the report. That would have to be taken a step further by the Housing Association. Also, constraints and paperwork requirements for connection, and also with the energy providers, the current energy providers, and as well any installation guidelines specific to that location of that building were not assessed. The brief, I've mentioned this slightly at the beginning in the introduction, is looking at how the PVs, the solar photovoltaics, would adapt appropriately to the selected properties. A filtering was performed in all three housing associations, looking at their wider housing stock and looking at properties that were ideally fit into these feasibility studies, and also looking at how those solutions would feed in to any funding and the economic side of things, applying the feed-in tariffs. and making it viable economically as well for the housing associations. Objectives, looking at the suitability of the dwellings, also looking at the constraints of the PV in that location, whether there's shading, whether there's anything that would conflict on the roof. Looking at the best array, the PV array for that location and that size of roof, that square metre and area of roof. Also looking at the technology and how that electrical output would feed back into the dwellings, whether it's in common areas or in the individual dwellings and flats. I've mentioned the electricity and the energy saving bills, how that would impact. And also looking at the paybacks, which is really important in these type of feasibility studies. How we're going to, all that investment from that housing association, how it's going to be paid back and in what timeline. One of the drivers that at least two of the housing associations really focused and applied and really brought this feasibility study to light was the fuel poverty. This was the case of Malcolm Holmes and East Hall Park. The Port of Leith Housing Association were focusing more on obtaining these economic benefits through the feed-in tariff and feeding them back into energy efficient solutions in the future in a wider scope. But at the end of the day, fuel poverty has been a key in the studies that we have today. As we know, fuel poverty is a big issue in Scotland and Britain as a whole. It focuses on the standards on energy efficiency, on the fabric, and also on heating and production of electricity in households. So it's really key that fuel poverty is reduced as much as possible. It's becoming an economic burden for a lot of people, a lot of families in Scotland. So trying to reduce that burden and trying to reduce that struggle is key. And by doing that with lowering energy bills, that can be a good factor and something that can reduce fuel poverty. As we know, fuel poverty is introduced the moment that a family spends more than 10% of their household income into energy. So if that level is over 10%, that is when families start getting fall into the fuel poverty and can be affected. As I say, many Scottish families are suffering from this. It's the fuel prices that are going up as well. The quality of housing is reduced. Maintenance isn't there in a lot of the houses. So that equilibrium is broken and fuel poverty kicks in. For every 1% of price in fuel, at least 40,000 more households can fall into fuel poverty. That's been part of a report by the Scottish Government showing those figures. So as I say, solar PV can produce a fraction by lowering fuel poverty, and that's why partly these studies have been created. I'm moving on to the methodology. This methodology has been applied to all three studies, so it's important to highlight what elements we looked at in a bit more detail and what information we got from the housing associations in order for us to create solutions and create alternatives for the solar PVs. The information that we required and really, the information that we included in our reports looked at basic elements of solar PV, for example, how PVs work and the benefits and the actual technology out there and all the different alternatives that we can have. Also, a brief highlighting any site constraints and how, for example, shading can impact a system and how it can reduce the efficiency of, or even stop the production of energy. So looking at elements like orientation, shading in a bit more detail, and maintenance regimes also important. An explanation of how the feed-in tariff has been applied and what constraints are attached on it, the different charges, the changes that have happened in the last 6 months, and elements of where and when to export that energy. Any grid connection constraints, there are different elements that have to be taken into consideration when sizing the technology. It's not just a matter of filling the whole roof area with solar panels. There are constraints out there that will give you different tariffs, feed-in tariffs, and also give you different problems with the grid connection. So that has been assessed as well. And in line with that, we've also asked for information on the current energy use for those households, whether it's for communal areas, how many kilowatt hours have been paid and needed for the last year, or when it's been individual households, how much energy has been used, how much electricity has been used for that past year as well. So in order to obtain a lot of the information and the sizing of this technology, we've really focused our study on obtaining information and getting as much information as we can on the buildings, and that includes the location, the tilt of the roof in a bit more detail with plans and sections across these buildings. That also brings in orientation, the best roof to take and apply this technology. Shading I've mentioned before, the roof dimensions, which we've taken again from the plans that were provided, the technology that's been out there, varying in most cases polycrystalline or monocrystalline technology, and also looking at the inverter type, the size of it, and how that can be used. We used a software called PVSYST, which can use this information that I've just mentioned to generate an estimated yearly generation per system. As I say, this electrical generation given to us in kilowatt hours per year was really important. The software also gave us the size of the system, whether it was a 4 kilowatt or a 10 kilowatt. Those were the two preferred sizes in accordance with the roof size and the roof dimensions, and those were the two kind of preferred. It also gave us different options on inverter size and different makes and different sizes, so that was important as well. But what was really important was, apart from the technology, was also looking at the economic viability. And in order to do that, we have a matrix and a spreadsheet that could give us different outputs in terms of the capital costs from the PVs and inverters. So that spreadsheet really looked at the capital cost of the material, the maintenance costs throughout a year or the different stages, inverter replacement, whether it's every 5 years or 8 years, depending on warranties and guarantees, the kilowatt generation per year from the PVSYST software, we would input that. Any changes in feed-in tariff rates were also part of the spreadsheet. The cost of electricity was also important in order to calculate the savings. So that was part of the spreadsheet and the economic elements. This is just an example of one of the properties where we obtained all the yearly electrical needs and the yearly use of electricity in that particular building, and we portrayed that in the report in order to get an indication of how much energy and what the target was in some cases in order to size the systems appropriately. We then came up with a matrix to look at the different technology and assessing whether we would go with polycrystalline or monocrystalline, and looking at the outputs of these and really looking at the pros and cons, the amount of panels that would involve, the amount of inverters, and the output, the yearly output. And then out of those three, in some cases 4 or 5 different alternatives, we would select one of them to conduct a bit more information and a more analysis on the actual location of these panels within that roof. And we can see the image below that, that in this example, the panels were appropriately located in the roof dimensions. We also looked at electricity export wherever possible at 3 pence per kilowatt hour. We looked at interest rates and payments if a loan was taken in order to pay the capital cost. We were also quite very important to focus on the paybacks and the periods within these 25-year periods. The reason we picked 25 years is because most of the feed-in tariff length of times were for 25 years for solar PV. So those were kind of the expected timelines that we looked at. Again, I've mentioned the bill savings plus the feed-in earnings to look at the payback periods, and also looking at the carbon savings which were applied as a result of that electricity being generated. So that was part of the whole methodology. These were applied to all of the buildings. It's worth mentioning that during this period of the work carried out for the feasibility studies, there was this change of feed-in tariffs before December 2011, and also before April 2012. So the studies have addressed these changes, and in some of the summaries we have done a comparison in payback between the two and the changes. Again, these are some of the outputs that we obtained in each case study, looking at the payback, looking at the capital cost investment against the feed-in tariff and the energy savings, and looking at when exactly in what year we would obtain a payback. And on the graph to the right, we've got the degradation and the electricity that is generated in the first year down to the 25th year, and how the efficiency of the panels is reduced slightly as the years go by, and also that blue line equates to the carbon savings as a result also declining. So that's been taken into account. I will now pass on the microphone to Michael Huey from Malcolm Holmes for a brief introduction on our first feasibility study for Malcolm Holmes.
Good afternoon, everyone. My name is Michael Hui. I'm from the Dunedin Canmore Housing Association and Malcolm Holmes. I'm the Energy and Sustainability Coordinator. Before I start this part of the presentation, I just like to express our thanks to the European Union Regional Development Fund and the CIC program of the Scottish Government for providing us with the funding to carry out this feasibility study through the CIC Start Online program. In my presentation, I'm going to talk a little bit about who Malcolm Holmes is, and then I'm going to tell you a little bit about why we actually require this feasibility study and our journey through the PV panels installation. And then I will pass that back to Julio, who will then explain a bit more details about the feasibility study. And then I will come back to tell you a little bit more about what and what's not expected from the feasibility study and what we think of it. And at the end, I'm going to tell you a little bit about where we are going at the moment after the feasibility study in terms of PV installation. Next slide, please. Malcolm Home is really part of a bigger group structure called the Dunedin Canmore Group, which consists of the Dunedin Canmore Housing Association, which is RSL operating. RSL is a registered social landlord operating in Edinburgh and the Lothian. We have currently just under about 4,000 property in our management. Some of them is actually in Fife as well. Malcolm Home, in fact, as Julio pointed out earlier, is the private arm of the Dunedin Canmore Group. We manage property which is market rent and mid rent, not the social rent. And we also manage some property which are on sale as well. Under Malcolm Home, we own about 300 property, but we also manage other property for other organizations. There is another company under the Dunedin Canmore Group, which is the New Horizon Property Services, which is a factoring company, and we currently have about 3,000 property under the management, under the portfolio, and they provide property services to other organizations or to private owner. Finally, we have Malcolm Professional Services, which offer a range of services to other people, and that's including property development agency services, maintenance work, including kitchen and bathroom replacement, and clerk of work services, energy assessment, and project management as well. And in this slides, we want to tell you a little bit about what we have been doing in terms of energy efficiency and sustainability as an organization. We didn't look at energy efficiency and sustainability just recently. We have been doing a lot of energy work in the past. Just over 10 years ago, we built one of the more sustainability advanced housing development in Edinburgh, the Slated Green Housing, and at the time is probably one of the leading forefront development in terms of sustainability. Since then, we have trialed various technology, including wind turbine, biomass boiler, solar hot water, and recently solar PV and also air source heat pump as well. We have our own sustainability policy and action plan, and they are actually run by a group of employee within the organization from various departments, and they are the sustainability working group, and they also act as champion within each department and each team to promote sustainability within the staff. We have our separate energy strategy and action plan, which come into being in the last year or so to address fuel poverty and various other issues relating energy, including the Climate Change Scotland Act, Scottish Housing Quality Standard, and various government initiatives. Just basically want to get ourselves more energy efficient. We are also one of the first small to medium-sized enterprise company in this country to take part in the Carbon Trust Carbon Management Program. We also have staff who are trained and qualified under the City and Guild Energy Awareness course, which qualify them to provide energy advice to the tenant. Can I have the next slide, please? Right. Our journey on the PV panels. PV panels, we have been aware of this technology for quite some time. Like any other registered social landlord, we haven't been able to install any PV panel or considering using PV panels in the past because of the capital cost of it. And then come the government feed-in tariff, which opened a window of opportunity for us to think about putting PV panels onto our development. In 2010, we were building 58 units of shelter housing in a regeneration area in Edinburgh. And in this development, we have a number of communal facility, like the resident communal lounge, laundry facility, scooter charger facility, and various meeting room, and also an office. And it makes sense that we put PV panels on this development to service the communal area to benefit the tenant collectively. So that's our first PV installation in our organization. And we put in a system of 10 kilowatt peak system in this development, and currently this development is fully occupied, and I understand that it's been running quite successfully. Next slide, please. While we are actually working on the shelter housing scheme, we realized that we have a bit of knowledge about PV panel. We want to extend that knowledge onto our existing property. And we started looking at selecting a few properties that we want to carry out pilot installation onto our existing property. We look at a few property, and we eventually actually got board approval in 2011, early part of 2011, to carry out more detailed study on 4 of our buildings. One is a city center based shelter housing scheme. Again, we are thinking of doing PV panel to service the communal area. Another one is in the Leaf Conservation Area, which is our homeless hostel. That is actually a listed building as well. We also look at our own head office and our workshop in Midlothian. This journey actually provides us with invaluable experience regarding PV installation and the design and the planning of it. We just learned get a lot of knowledge from that. Unfortunately, the installation will actually halt in October when the government announced the plan to reduce the feed-in tariff for PV installation completed after the 11th of December. We just wasn't able to carry that out by that deadline, so that installation was halted. But I will come back to that in this installation later. While we are looking at the retrofit pilots, we realize that we potentially want to extend our experience onto the rest of our stock and see how they can benefit from PV retrofitting. We look at various aspects of our property, but we soon realized that with 4,000 property on our hand, this is quite a big task to do on our own, and we think that we will need to get some help from academic or external consultancy. When we learn about the Kickstart Online program, we think that that is a wonderful opportunity for us to liaise with the academic consultant to look at that. As an organization, we have looked at the physical aspect, the physical aspect, the planning aspect, and the social aspect of our stock, and we are able to filter out some of the property for the feasibility study. But for structural, technical, and economic, we do actually require some help on those aspects. In our selection, through a filtering system, we select 6 of our property for the feasibility study. 2 of them is the shelter housing scheme in the city centre of Edinburgh, and then there's another 2 tenement blocks which is also based in the city centre as well. We have 1 development which got a biomass boiler as a communal heating system, which have quite a high electricity bill. And then finally, we picked 1 development which got individual houses, which we want to see how that will benefit the individual properties. Without further ado, I pass that back to Julio to give you the briefing on the more detailed study of our feasibility study.
Thank you very much, Michael. These are some images of some of the properties that we looked at and we addressed. After quite an extensive filtering of the best suited houses and properties as part of Malcolm Holmes, we selected 6 properties, as Michael was mentioning. These were located throughout Edinburgh, but mainly in the south and central part, with locations and houses, for example, Cathay Court, Lasswade Road, Firhill and Oxgangs, etc. So they were quite spread around the city. We concentrated on 3 for this webinar. These are the locations, sorry, around Edinburgh. We concentrated on 3 properties for this webinar, the Cathay Court one, Dryden Gate and Duff Street. And they were part of, I mean, these 3 were quite significant in the study, and as they had different constraints and different elements that were interesting to bring in this seminar. I'll start with Cathay Court. As I say, all the methodology that I've mentioned before has been applied to these studies, so I'll just show you some of the results. But just as an overview, Cathay Court, 4-storey apartment block, T-shaped building with a double centre split pitched roof. There are 2 areas or 2 nucleus within the building. One faces the Watcher of Leith, the canal area, and the other one intersects and perpendicular with away from the canal. The building was built around 1995, and it consists of 33 self-contained 2 apartment flats suitable for couples or single people, single occupants. What's important to highlight is that any energy that was going to be produced by the PVs in this case was going to be used for communal areas, and these would have been applied to a lift, lounge areas that obviously have lighting and electrical requirements, laundry areas, guest facilities, and any garden lighting external. These are images of Cathay Court. We can see that on the left-hand side we've got a bird's eye view of the building, where I've highlighted the optimum roof that was selected and used for this study. And in the same way, the photographs on the right-hand side, where I've highlighted again just where the panels have been envisioned to be installed. The image below is a view towards the Water of Leith. After using the PV-SYS software and after applying the cost parameters and the capital cost, we came up with a series of results. The PV-SYS software came up and we, together with the software, we arranged the panels accordingly on that roof that we selected, bearing in mind all the constraints, bearing in mind any service areas, any pipe work that was around the roof, etc., and also distributing it electrically as best as possible. So this was kind of the arrangement that we selected. In terms of some of the outputs and the results, after doing all our spreadsheets and calculations, and after assessing both feed-in tariff before December 2011 and after, and just before, just after the 4th April 2012, we looked at the payback comparison. So, for example, we had 8 years before as a payback, and now with this change in feed-in tariff, it goes up to 12. Carbon savings up to 97 tonnes for the whole 25-year cycle of the installation, with a number of 42 panels on the roof, giving us an array size of just under 10 kilowatt peak system. After the 25 years, it is estimated that just under 190,000 kilowatt hours would be produced, which is quite considerable. But in comparison with what is actually being used, we have an electrical demand in communal areas of 37,000 per year, and each year we would be able to produce 7,900 kilowatt hours. So, I mean, it's not 100%, but it's benefiting and producing quite a lot. I move on to Dryden Gate. Again, just an overview. Apartments built in the 1980s. We focused on 3 areas, 3 stairs within the complex that were very similar in roof type. They were appropriate for orientation as best as possible, and had a considerable roof space to accommodate PVs. These were stairs 1, 5 and 6. Very similar setting, very similar roof type and dimensions. So we analysed just one and estimated that could be replicated in the other 2. So these are some of the images. There's communal areas, external communal areas around it. So there's a lot of external lighting. There's an interesting kind of pathway around the buildings. So it's suitably for solar PVs. Again, this was the arrangement of the solar PVs for each one of those roofs, for those stairs. Divided into 3 strings, three circuits, with a total of 42 panels, and an array size for each one of them, again just under 10 kilowatt peak system. And very similar to the previous one, the payback between the 2 different feed-in tariffs, 8 years before December 2011, and 12 years just after the change in feed-in tariff. So obviously that's been an impact. And very similar to the previous one, we've got yearly generations against the actual electrical demand. In this case, it's over that demand, so a lot of that electricity could be exported back to gain another income from that. Following that, our final one with Malcolm Holmes was, for this webinar, was Duff Street. A more modern approach, a more modern, quite recently built set of apartments, 1993 blocks, In this case, Malcolm Holmes is part of and deals with these two properties, these two building apartments, 44 and 46, and it was again aimed at looking at electricity for communal areas. These are some of the images. We can see that tilt of the roof wasn't appropriate for that orientation and that location. And in this case, we did look at enhancing the tilt for the most appropriate and the best output of electricity. And again, we've got the split of the two roofs in the two blocks with this central maintenance pathway. So we tried to locate these on either side and distribute the panels appropriately. In terms of the results, similar again, because we're looking at the same, very similar size in PV array, in this case slightly lower, but 9.75 kilowatt peak, a bit less in panels, but very similar output yearly generation of 7,600 kilowatt hours, and just over the total communal area electricity demand. So again, fulfilling the communal needs, but exporting out into the grid. And finally, just a summary of all the properties. What's important here is really to highlight the carbon savings and the difference in payback from one feed-in tariff and another. And it oscillates between 4 and 5 years from one feed-in tariff to another. So that was important for Malcolm Holmes to take into account. And finally, some of the savings per different location. The lower CO2 savings from smaller systems, and the higher savings obviously from higher systems, and also that influences the feed-in tariff, etc. I'll now, just to finalise Malcolm Holmes, I'll pass over to Michael just to finish.
Thank you, William. The outcome of the feasibility study really fulfilled what we were expecting. On the list there, those are the items that we were expecting the report will fulfill, and most of it is really have been done. The last two items, the impact on addressing fuel poverty, that has touched on by the report, but we realize that to make detailed study of the fuel poverty issue probably will require a more detailed study separately. So, but we're happy with what is in the report about that. The investigation of various procurement methods, we didn't go into different kind of procurement method in details, but there's a very good study at the end of the report on rented roof scheme, which highlight a few issues that we have to watch out if we are considering going down to that procurement route. Next slide, please. One thing that I have to say is a little bit unexpected for us, but it's very useful, is the way the PV panels and arrangement were actually analyzed. There was 3 different options with different kind of PV panels and different arrangement, and that is unexpected for us, but it's going to be very useful. It's just going to help us to scrutinize on the specification of the panel better when we actually produce our tender document in the future, if we decide to go to do more PV panels. Following the study, what we have been doing is, or what has happened is, the study finished around about October, just after the government announced the reduction of feed-in tariff, and that's actually halt everything that we are doing, including the pilot, as I told you earlier before. After the new year, when we come back to work, we find that there's a window of opportunity for us to finish off the pilot, and we managed to do that in February. Since then, we also have a couple of new schemes that we have now put in PV panel. One is a 60 center new flatted development. Again, we use PV to service a communal area. We also have an experimental house in the south of Edinburgh, southern edge of Edinburgh, which we call it Eco House, and it's the first house that we can actually achieve in terms of energy performance of A rating. So that's very good news. We basically use PV panel there to power air source heat pump, so it doesn't rely on gas or rely on very minimal electricity to heat the house. Will we be doing any more PV retrofitting as a result of the report? We haven't got any immediate plan just now, but what the report shows us is that it's still financially viable. So I would not rule it out, and we definitely will be looking into that further. Thank you very much for listening to this part of the presentation. I now pass you on to John Monroe from East Hall Park Housing Cooperative.
Thank you, Michael. Appreciate that. My name's John McMorrow. I'm the director of East Hall Park Housing Cooperative. I'm going to give you a wee bit of background as to what we do and why we wanted to do the study and what we're going to do with it in the future. East Hall Park is a fully mutual housing cooperative based in the Easterhouse area of Glasgow, formed some 20 years ago. In fact, next Friday I celebrate 20 years doing the same job. I can't believe how grey I've got over the years, which is a bit unfortunate, but these things happen. And we have a small stock portfolio in relation to most. We only have something like 750 units, of which 695 are fully rented. Shared ownership, and a further 52 are factored. We have a turnover of 2.5 million, small staff team of 12, but we believe that we've got a proven reputation in doing much more than housing, and that's what we want to try and deliver as we look at how we can assist people in their communities. And that was really the focus for looking at this particular study. So if we move on to the next slide, it'll give you an indication as to our sustainability strategy. We wanted to initially make sure that people had awareness of what was required in relation to sustainability. So we undertook various training aspects, making sure that literature was circulated amongst the community, that the staff had an understanding of what we were trying to achieve, and we wanted to provide staff with basic skills to allow them to provide the basic energy advice that they needed to give to residents, remembering that residents and how they use their homes will have the greatest impact on carbon savings in the future. And as a consequence of that, we developed some energy advice and publicity materials. We did not just looking at solar panels, but in the past, when it came to our office, we actually installed wind turbines to ensure that we were trying to develop the whole sustainability strategy. We looked at a new build that we've recently just carried out in the last year, and we made sure that we got an eco assessment carried out, which is a very good rating, and we achieved that reasonably comfortably. And I suppose the next stage when it comes to new build is to think about how can we develop that to the excellent rating, and maybe looking at panels in the future. However, who knows what's going to happen in relation to new build developments, in relation to the HAG regimes and what funding is available. So that's in relation to the training, in relation to the new build development. If we move on now to the next slide, it helps us appreciate that when we looked at sustainability, it's about the whole environment. We even carried out an environmental project in relation to derelict land, an old school site that wasn't used. We created a new office. That's where we did the wind turbines as well. And when we looked at this derelict ground, we looked at the biodiversity, introducing native plant species into the area, and making sure that we upgraded and increased the lifespan by using mature trees so that we could create a whole biodiversity concept. And as part of that work, the general type of things that we looked at also was recycling, making sure households were aware of how they could recycle and have an impact on the planet and ecology, and educating communities in sustainability issues. So our focus has started from the people and specific projects delivered as a consequence of that. And if we move on to our next slide, we then realised, well, there's much more than just these projects. We had to look at the financial inclusion aspect and the poverty strategy that we've got. And the action plans that we're looking at are to make sure that that advice, the tenancy support to tenants, is continued. And we particularly wanted to focus in on financial exclusion and also to make sure that we dealt with the concept of fuel poverty. As Julio mentioned earlier on, the more that 1% increase, the significant that impacts on people who are in the greatest poverty and live or working in an area where there is lots of fuel poverty. We wanted to try and address that as much as possible. So we looked at early intervention schemes to assist people, help them maybe get the benefits from their electricity. We've identified vulnerable and at-risk groups. We're also trying to reduce the impact of fuel poverty in our housing stock. We're in a very unique position, and the majority of our stock is either new build or refurbished, with very few unimproved properties. In fact, only those that were inherited from Glasgow Housing Association in the last year. And that would be about 40, 50 properties that may actually not be improved. So we're in a good position where most of our stock is high energy efficient, but we wanted to go one step further. That's the reason for the study. And part of that work was to work with other agencies that can support us. And we're very thankful for the work that's been carried out in relation to the study. So if we move on to the next slide, what we're going to do is hand over to Julio, who will explain some of the technical aspects of the study, and later on we'll look at how we can benefit from it.
Thank you, John. Moving on to the actual case studies, very similar to the previous housing association, we selected 3 that were key to the study. In this case, as we can see in this image here, this is the East Hall Park sites. Number 1 is the East Hall development site, and phase number 2, or number 2 in that map, is the Kildare-Moray set of properties. Number 1 is part of this retrofit and area. It's a built-up area, and number 2 is part of an urban regeneration that's been undergone, where new builds in the last 5 years have been populating that area, and in this case, some of the PV solutions have been applied to already built recent houses and recent properties. So again, 6 properties were analysed, 4 in Easter House and 2 in this Kildare-Moray site, which was key to really addressing both areas. But what's important in both of them is that a lot of repetition of house type and roof type was quite beneficial to the study, because as I'll explain in the summary, a lot of the analysed properties, these 6 properties, could be implemented into other similar buildings that had the same orientation and the same roof type. So that was quite advantage. That was a good advantage, and a small calculation could be done on carbon savings, kind of estimated carbon saving. So in this case, we're going to be analysing Wardy Road, Ware Road, and finally in Kildare-Moray, the Arnisdale Road. Starting on with Wardy Road, it's a property located in the south of Easter House, in that site 1 that I mentioned in the first slide. Property that's already been refurbished. It's been part of this continued maintenance regime and improving the standards and the quality of life in these properties. This was conducted in the late 1990s. And most of them are flats for rent. The focus here is really to look at the output and the biggest generation to just distribute into individual flats. And in some cases, it could be applied into communal areas. But in this case, it was really to distribute around the flats in this property. The building is a standard timber structured roof with concrete tiles, and as I mentioned before, there's a lot of similarities in other buildings around that area where replication could be developed. This is one of the blocks on Wardy Road, and I've highlighted the building that we've concentrated this study. But as can be seen, the neighbours beside it, the different blocks around it can have the same methodology applied to it, obviously with a different procurement method, but it's the same orientation, same problem. So again, that can be installed similarly. These are some of the images of these apartment blocks, and very representative in all of the buildings. The building that we looked at and the software that we applied, all that information that I mentioned in the methodology, gave us this distribution of solar panels, with taking advantage of the majority of that roof, with the exception of that central element that's extruded out, just that could have portrayed some kind of shading, etc. So we kind of didn't look around that area. But in this case, the study was done before any changes were announced for for December 2011. So only the analysis for that payback was looked at. So in this example, 8 years payback, the number of panels would have been 40 in that example, with around 94 tonnes of carbon being saved throughout the 25 years. And those 40 panels would have are estimated to produce 7,700 kilowatt hours. In comparison with the actual electrical demand, it's lower, but appropriate distribution of that energy, whether on some of the apartments or just into communal areas, could work out quite well. Moving on to the next property, we've got Ware Road, very similar to the other one. In this case, it's an individual terraced set of terraced houses. A lot of them in this area with similar roof types. This one's located in the northeast of the Easter House development, and that's Site 1. We've got, it's a terraced house, and in this particular example, you've got people occupying the ground floor and other people occupying another family in the top floor. So the distribution of whatever energy would have been produced and is produced could be well managed in that case. Properties built around the 1990s, and as I say, it's all located as terraces. This is a bird's eye view, an image from the top. In this case, it's the end property of these terraced houses and this kind of cluster of buildings, but we can see similarities on the neighbours side by side. So the repetition can be applied. The image on the left is this property, and that's the roof that we analysed and that we saw appropriate in terms of the orientation, and which really gives you quite a clean roof to work on. And this was the kind of distribution of the panels in that case, again using the PBSys software for it. And in terms of some of the solutions, some of the outputs and the results, 40 panels on them, 32 tonnes of carbon being saved after 25 years, 11 years payback with a system of 4 kilowatts, as opposed to the others, which are larger, bigger roof space, obviously a larger system. In this case, it was just 4 kilowatts. and given us an electrical output of just around 3,000 kilowatt hours, and an estimated electrical demand for the ground floor and the first floor of around 6,000. So you are fulfilling a good part of the energy needs for that household. And finally, we've got 73 Arnisdale Road. As I mentioned, more recent properties within the last 5 years as part of this urban regeneration. But again, because it's already been built, it's related, and it's mentioned to be a retrofit because it's an add-on of technology. So in this case, it's a 3-storey house. The attic space has been used, so it's quite a large property with a lot of electrical demand for a large family. Again, we've got the bird's eye view from the top, and on the side, on the image on the right-hand side, the distribution of the panels in that property. And finally, some of the summary results. In this case, we're talking about 16 panels with a total generation per year of just under 3,000 kilowatt hours. And if we estimate the electrical demand for that property, for the size of it, you are reaching nearly, well, just over half of the needs. So fulfilling quite a lot, and having 11 years payback. It's a smaller system, so it takes the larger capital demand has that larger payback. And in terms of the results, as I mentioned before, a lot of replication in a lot of similar properties with similar orientation. So what we did in this example, in this report, was located all these properties that could have the same system as all the 6 analysed, made an estimated account of them, and those estimated carbon savings could be multiplied with the number of homes that are similar to give us an estimated carbon savings for that development, for both phases, for both sites. So that gave East Hall Park a good kind of roundup and panorama of what the savings could be, and the technology that it needed to reach it. And again, just a summary of the savings per property and how the different paybacks fitted into. And I think John is just going to summarise how well the report came in line with their expectations.
Thanks, Elio. Really must highlight that the report was excellent. One of the ways that we had initially anticipated carrying out the solar PV work was to actually go down the rent-a-roof model, where basically the tenants would receive all the benefits and we may get a small piece of funding. And one of the significant benefits of this report was it allowed us to analyse the information that was coming from the rent-a-roof companies to help us understand whether we were getting good value for money. So that was one of the benefits. Downside though was this was done prior to the change to the feed-in tariffs. So as a consequence of that, there has been 1 or 2 issues as to how we develop it further. We had initially anticipated having 180 units on site just after December, and unfortunately as a consequence of the feed-in tariffs, that's had a significant impact, and we're now re-evaluating how best we progress. Do we still continue with the rent-a-roof model, or do we look at maybe trying to self-finance that ourselves? Another issue that's maybe not mentioned in reports is the relationship with lenders and their views of the introduction of solar PVs to properties. We did experience some difficulties with the banks and the building societies who previously have security over our homes, and they were looking for us to then renegotiate existing loans because they said that the reality was the security or the value of the property would be reduced. However, we don't believe that to be the case, and we're now in negotiations with them. But that's maybe something to be aware of, is that the banks and the building societies are looking to recoup costs, so we need to be very careful when you go down the route of installing solar PVs. Our community and our committee are quite committed to the concept of trying to reduce fuel poverty. That will always be the driver for us. None of us were thinking about an income in relation to this, but we recognised that if we did get any income, we would offset that against other houses, and that's maybe very important to reflect if you do get any income as a consequence of this. But sound basis for us developing things further, and hopefully we'll be in a position where we can install solar PVs in the immediate future, but only time will tell as we look at the changes to the feed-in tariffs and the consequences of them ever changing over the years to come. And the other concept of what a community group is involved in the consultation that the government had issued. So we'll wait and see what happens in relation to that. So hopefully that gives you a flavour of our work, what we're trying to achieve, how we're community focused, and how solar PVs can assist not just older houses, but even recent new build properties, and because it's all about benefits for people. We're now going to move on to Wendy Farmer from Port of Leith, who will give us her experience of her study.
Thank you, John. Thanks. Yes, I'm Wendy Farmer. I'm the property manager in Port of Leith Housing Association in the Property and New Business Department. And we were very pleased to obtain CIC START funding to enable us to take part in this study. I'll give you a brief overview on the next slide. I'll give you a brief overview of Port of Leith. First of all, this is our vision, which is making our homes and neighbourhoods great places to live in. And there's an image there on the left-hand side of a recent development in Western Harbour, a recent platted development. So we can move on. Briefly, who we are: we're a not-for-profit social landlord and charity, and we provide high-quality, affordable homes in Leith and North Edinburgh. Our area of activity really stretches between Grantham in the west and Portobello in the east, going far as south as Binghamton